Hi guys, welcome to my YouTube channel. Today I am discussing here statistical process control. What is statistical process control? Statistical process control, shortly called SPC, monitors manufacturing processes with technology that measures and controls quality. SPC triggers various machines and instruments to provide quality data from product measurements and process readings. Once collected, the data is evaluated and monitored to control the process. Statistical process control is a simple way to encourage continuous improvement. When a process is continuously monitored and controlled, managers can ensure that it works at its full potential, resulting in consistent quality manufacturing. The concept of statistical process control has been around for a while. In 1924, Bell Laboratories employee Williams A. Shewhart designed in first control chart and pioneered that idea of statistical control. This quality control process was extensively used during World War II in facilities for ammunition and weapons. Statistical process control monitored the quality of products without compromising on satisfy safety. Modern manufacturing companies have to deal with constantly fluctuating prices of raw materials and a great deal of competition. Companies cannot control these factors, but they can control the quality of their products and processes. They need to consultancy work in improving the quality, efficiency, and cost margins to be a market leader. Inspection continues to be the key form of dictating quality issues for most companies, but its officially is debatable. With statistical process control, an organization can shift from being dictation based on prevention based, with the consultant monitoring of process performance. Operations can detect changing trend or processes before performance is affected. An overview of statistical process control tools. In total, 14 quality control tools are used in statistical process control, which are divided into 7 quality control tools and 7 supplemental tools. Quality control tools. First one, cause and effect diagrams, also known as the Ishikawa diagrams or the fishbone diagrams. Cause and effect diagrams are used to identify several causes of any problem. When created, the diagrams look like a fishbone, with each main bone stretching out into smaller branches that go deeper into each case. Cause check sheet. These are simple, ready to use forms that can be collected and then analyzed. Check sheets are especially good for data that is repeatedly under observation and collected by the same person or in the same location. Third one, histograms. Histograms look like bar charts and are graphs that represents frequency distributions. They are ideal for numbered data. Pareto charts. These are bar graphs that represent time and money or frequency and cost. Pareto charts are particularly useful to measure problems frequency. They show the 80 by 20 Pareto Pareto principles. Addressing 20% of the processes will resolve 80% of the problems. Scatter diagrams, also known as an XXY graph. Scatter diagrams work best when paired with numerical data. Stratification. This is a tool to separate data that simplifies pattern identification. Stratification is a process that sorts objects, people, and related data into layers or specific groups. It is perfect for data from different sources. Control charts. These are the oldest, most popular statistical process tools. Mental tools. Data stratification. A slight difference from the satisfaction tools in the quality control tools. Defect maps. These are maps that visualize and track a product's defects, focusing on physical locations and flaws. Every defect is identified on the map. Events logs. These are standardized records that records key software and hardware events. Process flowcharts. Process flowcharts are a snapshot of steps in a process displayed in the order they occur. Progress centers. When decisions need to be made, progress centers are centralized locations that allow businesses to monitor progress and collect data. Randomization. Randomization is the use of change to assign manufacturing units to a treatment group. Sample size determination. This tool determines the number of individual or events needs to be included in the statistical analysis. Benefits of statistical process control. Statistical process control have a range of benefits. First one, reduce wastage and warranty claims. Second one, maximized productivity in a manufacturing unit. Third one, increasing operational efficiency. Fourth one, reduced need for manual inspections. Fifth one, enhanced customer satisfaction. Sixth one, controlled costs. Seventh one, improved analytics and reporting. These are the benefits of statistical process control. To use statistical process control. As with any new process, the first step to using statistical process control is evaluating where the manufacturing business is facing waste or performance issues. This could be related to reworking products, wasting entire range of products, or long inspection times. A company benefits by applying statistical process control systems to this trouble area first. Collection and recording of data. Statistical process controls data is collected in two ways. First, as measurements of a particular products, and second, as process instrumentation readings. Once recorded, this data is tracked with several kinds of control charts specific to the type of data collected. Using the appropriate chart is imperative to gaining useful information. Data is either the continuous variable or is attributed data. Collecting and recording data can be individual values or can be the average of a set of readings depending on what the organization needs. Analyzing the data. During analysis, all data points recorded on the control chart have to be within control limits as long as there are no special cases. Common causes results in data points falling within control limits, but special case tend to be outliers. To classify a process as being in statistical control, there should be no outlines on any chart. When a process is in control, it will not have any identified special causes and all the data will fall between control times. Disadvantages with statistical process control. As with any process, there are some disadvantages to statistical process control. First one, time requirements. While the emphasis of statistical process control is on early detection, implementing the system in a manufacturing setup can take a long time. Additionally, the process of monitoring and filling out charts is time consuming since the system has to be integrated into an existing framework. Training of personnel is required, which takes time. Second one, cost consideration. Statistical process control is also an expensive affair and requires that a company signs a contract with a service provider and invests in training resources and materials. Third one, quality measurements. A problems with statistical process control is that it detected when there is non-conformance in the process protocol, but it does not say how many products may be defective up until that point. The future of statistical process control. By stabilizing its production process, an organization can reduce the number of variations in productivity, benefiting both the consumer and the company. While the consumer gets a safe and well tested products and the company benefits by reducing the costs of production and any embarrassment that arises from a defective products. As machine learning and artificial intelligence advance, the abilities of statistical process control will increase. This will lead to bigger gains for the manufacturing, increased competitive advantage, and satisfied customers. These are the statistical process control in manufacturing. I hope you like this video. Please like, share, comment and subscribe to my YouTube channel. Thank you.